All right, Assata, we ready?
Yeah.
All right, bet. All right, check this out. All right, so you ready? All right, cool. All right, so this is Professor Parker, and this is All This Math, IG Live, and today I have a TA. My teacher's assistant is Assata, named after Assata Shakur. Look her up if you're unfamiliar with Assata Shakur. Shout out to her. And Assata's going to help me multiply some fractions. All right, we have 3 examples up here. And Assata's going to help me multiply some fractions.
Yep.
Right, Assata? All right, cool. So listen, we're going to talk about the technical aspect of multiplying fractions and also something called cross-canceling. Because cross-canceling is something that we all should know how to do because it makes our life easier and it makes multiplying fractions easier. Now, conceptually, what actually is taking place when we multiply fractions, we're not going to get into too much of that today on this particular video or this particular live. I'm going to do that at another time because that's very important too. Because I think a lot of people have issues with fractions because they really don't understand what is really taking place when you say 3/4 times 1/3. Like, what does that really even mean, right? So we're going to do another video, right, about that, you know, at another time. But for today, we're going to keep it kind of brief.
And stick on this.
Well, I mean, we could use the same problems or we could use some different ones. But today we're going to keep it kind of brief. And what we're going to do is we're going to just talk about multiplying horizontally, straight across, and cross-canceling, going into diagonals, all right? To make our work easier, right?
Yeah.
All right, so, Assata, if you could read number 1 for us out loud.
Okay.
Do you know how to read that?
No.
All right, cool. I'm glad you were honest, right? You know, there's no shame in that, right? She doesn't know because I haven't taught her this yet, right? And her school hasn't taught this yet because Assata's in the 2nd grade, and this is not on the curriculum until the 3rd grade, right? Multiplying fractions is not on her curriculum, but we don't need to wait for them. We can teach our children what we feel they're ready to learn when they're ready to learn it, all right? So she's learning this right now. All right, so this is 3/4, right? This is a fraction. That's called your numerator. That's your denominator. So we got 3/4, right? 3/4 or 3/4. It's like with money, right? Like a fourth is a quarter, which is 25 cents, right? So if you got 3 of those, that's 75 cents, right? Look, now see him trying to come down and be in the video. He can't though. All right? So look, we got 3/4, right? Times 1/3. All right? 3/4 times 1/3. All right? Now, when we add and subtract fractions, we need something called a least common denominator. But we're not adding or subtracting. Today we're multiplying. So we don't need a least common denominator. And the least common denominator is something that we're going to talk about in another video as well, when we add or subtract fractions, all right? So dig this. One way we can do this is just multiply straight across. So now Assata's been working on her multiplication facts and her multiplication table, right? She's been going in with those like real heavy, right? Because I think that's the foundation for any mathematics, all right? Understanding the multiplication table. What's up? Let them know. Tell them what you did today.
I did one today by 15s. I used to do 12s, but now I moved up 3 more numbers
all right,
to
so
get to 15.
What Assata's trying to tell you is that she had to level up. Because initially she was doing 12 by 12 multiplication templates and she was filling all the numbers in, right? Doing the multiplication. But now she had to level up. Now she's doing 15 by 15 multiplication tables, right? She's a problem, all right? Right? She goes hard with this multiplication. All right, so now what we're going to do is we're going to multiply straight across, right? Now, Assata, tell me, all right, what is, no, I don't need you to write it. I don't need you to write it. Okay. So you don't need the chair, all right? Tell me what 3 times 1 is.
3 times 3.
It's 3, because anything times 1 is that number. So that means our numerator in our product, and the product is what we call the answer in a multiplication problem, is going to be 3. All right? Now, then we need to multiply the denominators. So what's 4 times 3?
4 times 3. 12.
It's 12, right. Boom. So that's going to be our denominator. All right? Now, here's the thing. This fraction is 3/12, so 3 out of 12. We need to always reduce our fractions if ever possible, or we could say simplify our fractions if ever possible. Now, the question you should be asking is, how do I know when I can reduce the fraction? Or how do I know when I can simplify the fraction? This is how you know, Assata. You look at the 2 numbers, the numerator and the denominator, and you ask yourself, is there something called a GCF?
What is that?
Good question. What is a GCF? GCF is an acronym that stands for greatest common factor. All right? Greatest common factor. All right? Which really just means that's just like mathematical language and jargon for what's the biggest number that divides evenly into each of these. So that's what we got to think about. We got to think about what's the biggest number that divides evenly into 3 and also divides evenly into 12. Now I'm going to tell you, the biggest number is that satisfies that scenario is 3. Because 3 times 1 is 3 and 3 times 4 is 12, right? Mm-hmm. So we're doing division really, and we didn't even get into division yet, but you're gonna catch on, right? So what is 3 divided by 3? 1. 3 divided by 3 is 1. So you cross the 3 out and write a 1, right? Mm-hmm. And then what you also do is you do the same thing with the 12. You do 12 divided by 3, cross the 12 out, and you get a 4, right? So now what I'm left with is 1/4. So that's the final answer. 1/4 is the final answer. All right? All right, so that means that 3/4 times 1/3 is equal to 1/4. And again, like I said, we're gonna spend some additional time on another video and talk about the actual concept and like in real life, like what does 1/4 really mean, and why is 3/4 times 1/3 equal to 1/4? We're gonna talk about that at another time. But right now, we're just talking about the technical aspects of how to arrive at the answer or at that product. All right. So look, we didn't cross cancel though. We could have cross canceled, but we didn't cross cancel, right? So it's like a now and later type of thing. We can either simplify now in the beginning of the problem, which will be cross canceling, or we can simplify later like we did this way when we did the problem. All right. So this is what I'm gonna do. I'm gonna erase this, and we're gonna do this again. No, you too short. I'll erase it. I got it. But thanks for offering though. So we're gonna erase this, and what we're gonna do is we're going to cross cancel. Now, when I say cross cancel, I mean I go diagonal and I look for any GCFs. Oh, my marker's running up.
Here, use mine.
Use yours? All right, cool. Put that in my pocket so I don't forget to throw that away. All right, so look. So you first look at this diagonal, the 3 and the 3.
Which circle your GCF?
Yeah, you're right. Boom. GCF, greatest common factor. All right, so now I look at the 3 and the 3, and then I say, okay, well, what is the greatest common factor of 3 and 3? Or what is the biggest number that divides evenly into 3 and into 3? And that number is 3 itself, right?
Yeah.
So 3 divided by 3 is 1. And 3 divided by 3 is 1. So now, and I also look at this diagonal, the 1 and the 4, and I ask, is there a common factor between 1 and 4 besides 1? Because 1 is a common factor with just about everything.
Why did you put the 1 on the bottom on that?
Good question. Because I divided by 3, and 3 is the GCF. 3 divided by 3 equals 1, because 3 goes into 3 one time. Because everything goes into itself one time, right? Because you can fit a 3 into 3 once. There's only one of them. And the same thing up here, 3 divided by 3 is 1. All right? So now, since I did my cross canceling, and I can't cross cancel on this diagonal with the 1 and the 4. I can't do it. Because the greatest common factor is 1, and that doesn't change anything. So now I multiply horizontal. And I do 1 times 1. And what's 1 times 1?
1 times 1 is 1.
It's 1, right. So that's going to be my numerator. The top number, my numerator.
It's not the same thing as 1 plus 1.
Right, because what's 1 plus 1?
2.
Exactly. It's not the same thing as 1 plus 1. Remember that. All right? So now I got 4 times 1.
1 is like, and when you're doing multiplication with a 1, it's like 0 plus a number. Like 3.
It's
and
similar.
then you'll get 3.
Right. It's similar to that because exactly. So what she's doing is she's combining concepts. She's noticing similarities between concepts, between the concept of adding a 0 and multiplying by 1, because you end up with that other number, the number that you started with, right? Mm-hmm. Because 3 plus 0 is 3, and 3 times 1 is
3. Also
3. All right. See, I like how you do that. You sharp. Gotta keep you around. All right. So look. So, but what about 4 times 1?
4 times 1. 4.
It's 4, like you just said. Now, isn't this the answer that we got when we did it the first time? After we simplified? But notice we don't have to simplify. Because when you cross cancel, you don't have to simplify later. You can simply, because cross canceling basically means you're simplifying within the problem originally. All right, so that's our answer, 1/4. All right, now let's look down at number 2. So Assata, this was read 3/4, and that's 1/3. So how do I read this fraction?
7/8.
7/8. Exactly. So we're saying 7/8 times. How do I read this fraction?
I don't know.
Okay, 4/21.
4/21.
4/21. It sounds weird, right? It does sound weird, but that's how you write it. That's how you say it, though.
It sounds like the number that the day is in the date.
Okay. Like it is. It is like the 21st of April or the 21st of March, right? All right. Let me see. Okay, I was about to say something. I lost my train of thought. All right. So anyway, now I want to try to cross cancel, right? Because these numbers are real big, right? Because I could do 7 times 4, and you probably know what 7 times 4 is, don't you? What is it?
28.
28, right? We could do that, but then what about 8 times 21?
8 times 21. I don't know.
It's a huge number, right? Very huge. All right, so we don't want to deal with that. What we want to do is we want to cross cancel. All right, so I got a 7. I look at this diagonal. I got a 7 and a 21. And then I need to ask myself, what is the GCF of 7 and 21? So that means the biggest number that divides into 7 and 21 is 7, right? It's 7. So that means I need to divide this by 7, and I need to divide this by 7. Now, 7 divided by 7 is going to be 1, and 21 divided by 7 is going to be 3. All right? So now we simplified this 7. This 7 is a smaller number now. Now it's a 1. This 21 is a 3 now.
Why is it 3?
Because 7 goes into 21 3 times. And this is a 1 because 7 goes into 7 1 time. So it's something called reducing fractions that we're basically doing. All right? That's basically what we're doing by cross canceling. Now, look at this diagonal. You have an 8 and a 4. And then we have to ask ourselves, does 8 and 4 have a GCF as well? Does 8 and 4 have a GCF? 8 and 4 does have a GCF. The biggest number that divides into 8 and 4 is the number 4, right? And when we talk more about division, you'll catch on to this. So now, what is 4 divided by 4? 1. Anytime you divide a number by itself, the quotient, that's the answer when you divide something, is 1. Now, what about 8 divided by 4? 8 divided by 4 is 2. All right? So now, this became a 1 because 4 divided by 4 is 1. This became a 2 because 8 divided by 4 is 2. So now, I do my multiplication, and now I do my horizontal multiplication. So tell me what 1 times 1 is, Assata.
1 times 1 is 1.
Right. Now, for the denominators, the top numbers are called numerators. The bottom numbers are called denominators. So, when I multiply the denominators, or 2 times 3, what do I get?
2 times 6.
Right, that's my denominator. And I can't reduce this anymore. So this is my answer, 1/6. 1/6. So that means that 7/8 times 4/21 is equal to 1/6. All right, and we cross cancel. All right, and cross canceling made our multiplication easier because we divided in the beginning when we cross cancel. So it made our multiplication much easier. Now go down to number 3. Number 3, we got 5/6 times 36/25. Now this fraction is crazy. It's called an improper fraction.
What?
It's called an improper fraction, not because the numbers are large, but it's because the numerator is larger than the denominator. Whenever your numerator is larger than your denominator, there's a term for that. It's called an improper fraction. All right? But we still can cross cancel, and we still multiply the same way we did in number 1 and number 2. So what you do is you look at the diagonals. You see 5 and you see 25, right? And then we look for a GCF, greatest common factor. So the biggest number that divides evenly into 5 and the biggest number that divides evenly into 25. So so that number is 5. I'm going to just let you know that number is 5. 5 divided by 5 is 1. And then 25 divided by 5 is 5. Now, for this diagonal, the greatest common factor, or the biggest number that can divide into 6 and into 36, is just 6. All right? So I'm going to do 6 divided by 6. That gives me 1. Because remember, whenever you divide something by the same number or by itself, the quotient is 1. And then when you do 36 divided by 6, that gives you 6. Because 6 times 6 is 36. So if 6 times 6 is 36, then 36 divided by 6 will equal 6. Because division is the opposite of multiplication. Right? And that's a way to check your work also. All right? So now, I cross-canceled with this diagonal. I cross-canceled with this diagonal. Right? And cross-canceling is real cool. I remember I learned how to do this years ago. And I always thought it was real cool because it makes the work easier. You know? So anyway, now we can multiply horizontally. So we multiply this 1 by this 6. And what's 1 times 6?
6.
Exactly. I draw my fraction bar, and then I multiply the denominators. 1 times 5. What's that equal? 5. So I have 6/5. Now, this is an improper fraction. Now, I'm going to show you, all right, just in case eventually you need to know how to do this anyway. I'm going to show you how to convert from an improper fraction to what's called a mixed number. All right? It's called mixed because it has a whole number part and then it has a fraction part. It's a mixture. All right? Whole number, fraction. All right? So now, what I think about is when I look at the denominator, it's a 5. I ask myself, how many 5s can fit into 6? Or how many times does 5 divide into 6? 5 can divide into 6 only one time, right? But it doesn't divide evenly into 6. It has a leftover or a remainder. If 5 goes into 6 one time, 5 times 1 is 5. So then you ask yourself, well, what's the difference between the 6 and the 5? Because 5 times 1 is 5. The difference between 6 and 5 is 1. So that means there's a remainder of 1, or there's a leftover of 1. So that's going to be my numerator, because remember, it's a mixed number. It's got a whole number part, and then it's got a fraction part. And then my denominator never changes. So if my denominator was a 5, my denominator is still a 5. So this will be the final answer. But these are equivalent, right? When you get into algebra, we don't really deal with mixed numbers. We deal with improper fractions. Improper fractions are cool when you get to algebra, but in like pre-algebra and lower level, like arithmetic, for some reason we don't like improper fractions. I don't know. I don't have a problem with them. I think they're cool, But anyway, so this is multiplying fractions with cross-canceling. I just wanted to introduce that concept. As I said, we're going to do subsequent videos at other times about the concept behind multiplying. We also are going to talk more in detail about what a greatest common factor is and how you find the greatest common factor and how you know like what number to divide by. Today I just gave you the GCF. I didn't really talk about, in the interest of time and my focus on this particular video, I only wanted to talk about how to cross cancel. All right, but we have time. We're gonna get into that in some other videos. All right. So yeah, we're finished. Anything you want to say?
No.
All right.
Something I would like to write.
All right. Okay, go ahead. So I just want to thank my TA, my teacher's assistant, Assata, for helping me out today with this process and going over these 3 questions. And again, while you are doing your studies, whether you're doing online assignments, whether you're doing work packets, if you have any math questions that give you trouble, please don't hesitate to send a DM to the All This Math Instagram page, and we'll do our best to work out your problem on this board. Anything else you want to say?
No, I read it.
You good? Oh, bye-bye. Okay. All right. Peace.